Well, hello again. This is Ricardo Borges, and I'm gonna do another walkthrough. This is for NMRfilter, the tool that we designed it for compound identification in mixtures using HSQC, HMBC, and HSQC-TOCSY. We are running it today on Jupyter Notebook, just because I want to show you how easy it is to use it. So we have the GitHub page. It's located on Stefan Kahn's page for NMRfilter. We download that. This is our NMRfilter folder. Okay, so as it is on the README file, this is the line of use. We need that. Copy. Go for Anaconda prompt and run it. It says okay, and then we run Jupyter Notebook. In my case, I'm gonna go for the D drive, right? Jupyter Notebook will open on in here. This is my Edge navigator, and I can navigate to NMRfilter, where I can find the files that I downloaded from GitHub. Okay, let's open the notebook, NMRfilter notebook file. And in here we have our notebook. You can see some nice introduction, some nice well, text, markdown text, and then we start for the code cells, right? Counter enter to run it. This is just to import certain dependencies. Here we'll be able to select the project that we are gonna be using. Let's go for these Brugmansia alkaloids. To tell you about this, well, I have another folder here. Name it. This folder is this one. So in one folder I have the software, and then in another folder on the same locale of the main folder, I have a folder named NMRfilter projects, and inside this folder of the projects, I'm gonna have several projects that I'm running. Okay, so let's keep that open, and then I select here. Let's go for this Brugmansia alkaloid example. Go for the next cell. The cell is showing the properties that we choose for to apply the methods. This folder is in here. We can open that just to see. Let's go for Notepad++. And since I'm on Windows, this is the important thing I have to do. I have to set the path for the projects. Okay, and since I'm working on Windows, I have to do this format here. Otherwise, it has some issues with Python, right? Okay, in here, there's just another cell calling up some definitions for these parameters that we use. You can run that, and it will bring the definitions, and this will do the part of the predictions. Okay, we wait a moment. I'm not speeding up this video or anything, just for you to see how quick it is. Okay. This is just some warnings about the simulation. And this is the NMRfilter itself. Clustering, detecting communities, calculating best hits, and the results is showing here. It's a table showing the structures that was submitted as candidates for each project, the names associated to each structure, and the parameter is distance and standard deviation to say how close their data, these simulated data, are close to the experimental data. The standard deviation will tell how they are clustered within these HMBC files, and matching heights, which are interesting for us to see. So this final part is just to call an image. We can call different image. These are the compounds for the candidates, right? So let's go for IUCNM and just check this, how the figure is shown. You pop this up. So this is the figure. We can see some nice matching heights, right? I have 9 of the 10 expected peaks. They're matching, and some of the HMBC are matching as well. You can see the connections going on here in the HMBC. This is as expected. Okay, so I have the identification of this compound, iosinamin, and I can even see quaternary carbon for the identification, which is great, right, in many cases. Okay, so this is it. Thank you.